Okay, students, welcome to the demonstration on potential differences and electromotive force. We've just covered this chapter in the PowerPoint slides. Hopefully you all have watched it. And what we have here today is a few of the common circuit components that we are going to use. Of course, the most important star for the day is our voltmeter. Our voltmeter can measure the potential difference across components of a circuit and even measure the EMF of a source. Okay, and of course a circuit will not be complete if we don't have a source of EMF that can convert chemical energy stored inside the sealed lead acid here into some form of electrical energy where it drives charges around the circuit, just as we have discussed before. Okay, this EMF source is rated to have, let me zoom in for you all to see. Two volts, if you all can see it. Yeah, okay, it has 2 volts given by this point here. 2 volts, okay? So, together the EMF source, okay, which is our sealed lead acid battery here, it has a positive terminal denoted by the color red and a negative terminal denoted by the color black. See? Okay. So actually taking notes of which of these terminals we are going to use is important. So electrons flow out of the negative terminal and back in through the positive terminal. But since we are using conventional current, we imagine positive charges coming out of the red terminal. Okay, so other than this, we also have some wires attached to crocodile clips at the edge. Okay, and we also have light bulbs. Okay, so the first thing we're going to do today is we are going to measure the EMF of the source. Okay, the source says 2 volts. Let's check whether it's as what the manufacturer claims. On the voltmeter, there is a red terminal which denotes positive and a black terminal which denotes negative, just like the EMF source. Now, in this case, we are going to connect the red terminal to the red terminal and the black terminal to the black terminal. Okay, and what do we have? We have an EMF of 1.9 volts, so it's 0.1 volts less than what the manufacturer claims. Okay, what happens if we reverse the ends of the terminals? Let's see what happens. See, now the arrow goes into the negative portion of the voltmeter. So for a voltmeter connected to a source of EMF, we usually want to connect the positive terminal to the positive terminal and the negative terminal to the negative terminal. Okay, that will give us our EMF. Okay. Now let's create a very simple circuit using light bulbs. Okay.
How come you know in our team?
Next year.
Huh?
Next year. Okay, so we have 2 light bulb connectors. What they do is just hold the light bulb in the proper place, so we have nice leads coming out of them. Okay. Okay, so I'm going to screw the light bulb in. Okay, so let's just start with a very simple circuit of 1 light bulb. Okay, so we're going to have the positive terminal of the EMF source connected to 1 terminal of the light bulb and the negative terminal of the EMF source connected to the other terminal of the light bulb. Okay, let's see what happens. Okay. Now that there is a source of EMF, the light bulb can light up. Because what's happening here is that the battery here is converting chemical energy that is stored inside it into electrical energy, which moves in the circuit. When the charges move past the light bulb, okay, they convert that electrical energy into light energy. So this is one of the uses of electricity that we have. Of course, there are many uses. Sometimes we convert the electricity into electrical energy into kinetic energy, like when you want to use a washing machine. Sometimes we do it into a heat energy, like a heater, okay, where we use to boil water, for example. Okay, so there are many uses for electricity. It's one of the best modern days inventions that made human life so enjoyable. Okay, so now we are interested in measuring the potential difference across the light bulb. Okay, first we are going to do it without the source. Of course, if we do not have a source of EMF, charges cannot flow across the circuit, right? So now it is just a very simple setup. We are connecting the voltmeter to the light bulb, okay? And the voltmeter reads 0. Of course, because now we have no source of EMF. Now we are going to measure the potential difference across the light bulb after we have connected a source of EMF. Okay. So now we have a simple circuit with the light bulb. We are going to connect the voltmeter in parallel with the light bulb. And if you can see, the voltmeter reads just slightly less than 1.9 volts, which is the EMF that the source provided. So this is one way of looking at it. It's like the conservation of energy that you all learned earlier in work energy power. Whatever electrical energy is being supplied by the EMF is being delivered to the light bulb, and that's why we measure a potential difference of 1.9 across the light bulb. Okay, now what would you expect if instead of just one light bulb, we have two light bulbs? Okay? Now we have two light bulbs in series, but because we only had one source, they are much more dim, right? Because whatever energy is being split in between the two bulbs here. So this is connection in series. We have the source going into one light bulb, and then coming out of this light bulb, going to the next light bulb, and connecting back to the other terminal of the source of EMF, which is our battery. Okay, now let's measure the potential difference across both of these light bulbs. Okay, as expected, the potential difference across both of the light bulbs is nothing but 1.9.